Dose measurement in brachytherapy is important to ensure treatment effectiveness, also patient safety. So, how do we measure it? These are dosimetry technique used in brachytherapy with different strengths for clinical or experimental need. Radiochromic films darken in response to radiation and provide high spatial resolution. Though their response is energy dependent and nonlinear, proper film selection minimizes this. Dose can be mapped using densitometers or scanners. The darkness tells us how much radiation was absorbed. Once calibrated, these self-developing films accurately visualize dose in external radiotherapy and brachytherapy. TLDS absorbs radiation energy and release it as light when heated. They're compact and commonly used for point dose measurements. When heated, electrons jump to the conduction band, then fall back to releasing light. Measuring this light tells us the absorbed radiation dose.
Now, let's talk about the ionization chamber, which is the gold standard for dose calibration.
When radiation passes through its gas-filled cavity, it creates charged particles. These generate a tiny current, measured by an electrometer and converted to dose. For brachytherapy, we use ultra-small chambers, just 0.01 to 0.6 cc, to minimize errors in steep dose gradients. Now, polymer gel dosimeters, a revolutionary 3D approach. These gels contain special monomers that polymerize when irradiated. After exposure, an MRI scan detects these changes, transforming them into detailed 3D dose maps. This lets us validate complex brachytherapy dose distributions that other tools might miss.
A solid-state detector radiation interaction charged particles or photons strike the semiconductor generating electron-hole pairs. A reverse-biased p-n junction creates a depletion region where electrons move to the positive electrode and holes to the negative electrode, generating current. Signal amplification. Integrated electronics enhance the signal for improved accuracy and response time. The amplified signal is converted into voltage or digital data. Radiation excites electrons in a scintillator, producing light. This light hits a photomultiplier tube, PMT, releasing photoelectrons. These electrons multiply across diodes, amplifying the signal. The final pulse's strength reflects the radiation's energy, and pulse frequency indicates intensity. So, I'll briefly compare dosimeters used in brachytherapy based on how well they work in clinics and research. Since accurate dose measurement is key for safety and treatment, the right dosimeter depends on its precision, detail, and ability to give quick results. Let's look here. Ionization chambers are the clinical standard for source calibration. TLDs are small and accurate, making them ideal for in vivo dose checks. Radiochromic film offers high-resolution 2D dose mapping. Polymer gel dosimeters, enabling 3D dose distribution studies. Solid-state and scintillation detectors are great for real-time measurements. To conclude, ion chambers and TLDs dominate in routine practice. Polymer gels and scintillators support advanced research. Radiochromic film offers a versatile bridge between the two. Ultimately, the dosimeter choice depends on the clinical need or research goal. That's all. Thank you.